In this video, I'm going to introduce the ESP32 camera module. I'm going to show you how to set up the program, set up the connectivity so the camera can work and display the video over the Wi-Fi. I'm going to show you to use these UART to USB different modules including FTDI, or you can use your Arduino Uno compatible or Arduino Uno or any other Arduino that you have. You can program this Uno compatible to program this, and make sure to connect this jumper. Let me measure the current. I'm connecting it. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This module is sold between $10 to $15 depending where you get it from. The configuration is very simple, straightforward, but you have to be able to upload your code through certain method and way because the module does not have USB connectivity. So you have to be able to use either FTDI or other UART to USB converter, or even Arduino IDE or other module, which I'm going to show you. In this video, I'm going to demonstrate to see the video over the Wi-Fi network within the same network of your home or business, whatever you have. But in a separate video, I'm going to show you how you can see the video over the internet from any other location across the world. This is the camera module. Usually when they ship it, the camera usually will be not inserted when you receive it. So I'm lifting this brown piece like that. So you lift it and remove the camera. Camera is facing up, and that is the camera. Then we have also micro SD card reader here, which consumes a lot of power, but when I use this, I'm going to show you the amount of current that this consumes. And on this side we have the ESP32S module. It has an antenna, but it has also external connection that you don't need at home. It will work, but if that is needed, it needs a little modification, which I will not go through that. And the module does not have any USB. This is a 3.3 volts chip. We have a reset button, and we're using few pins of this. Length of the module is 40 millimeters. The width is 27.1 millimeters, around 11 millimeters, 11.8 millimeters. For the camera, make sure that this gray portion is up like that, so you can lift it up. Insert the camera and hold it and press this. Now the camera is ready. To operate this device in terms of power supply, you can connect 5 volts here, or you can connect 3.3 volts. We have ground here and ground here, and there is another ground. The reason that you can connect 5 volts is that you can connect it from Arduino Uno or USB or another device, and that 5 volts comes here and it's being converted to 3.3 volts that supply the voltage to the microcontroller. And we have a reset switch here that if you want to restart the microcontroller, you press this. This chip here is IPS6404 64 megabit, which is 8 megabyte Internet of Things RAM. This is a RAM or memory for this chip and for the camera, so it can process smoothly. And here is a data sheet for it. The chip is IPS6404LSQ. It's 64 megabyte RAM for Internet of Things, and here it says IPS confidential for this use only. Besides 4 megabyte RAM on the ESP32 chip, we also have 8 megabyte extra RAM here to facilitate the smooth process of video. Here is the data sheet of the manufacturer of the camera. The resolution of the camera, if the picture is taken or set with JPEG, depending on the type that you set, QQVGA, that's 6 frames per second, that's 7 frames per second if it is VGA 7, and SVGA 8 frames per second. And if we set it to grayscale, it would be 9 and 8 in these values. and the pins in terms of connectivity from the device to camera are in this order. The camera pins are these, and these are the pins for ESP32, and these are the SD card pins, and these are the ESP32 pins that have been connected internally. This is a data sheet for the OV2640 camera. It's a CMOS UXGA 2 megapixel camera, and the resolution is 1632 by 1232, 8-bit or 10-bit. I'll provide you the link so you can download this and have a look at it if you want. I've created this camera module pinout. I'll provide you the link to download it, the camera and the module. These are the GPIO pins that are at these locations. So when you see the antenna and these chips towards you, these are the pins, and these are your USB pin. You need to connect only 4 wires: ground, RX, TX and 3.3 volts. You can also connect it 5 volts. If you have 5 volt source, you can connect it the 5 volts of your external source connected in here instead of 3.3. So pay attention, this UOT, this is the UART, TX and then RX. So TX is connected to RX and RX is connected to TX. This is receiving from transmit. So this transmits and this is receiving. And as I'm going to show you, when you update the code, you need to connect a jumper female to female, and you insert it here between ground and GPIO 0. Once you upload the code, you have to connect it, and once the code is finished, as I've mentioned here, first remove the jumper after finishing the upload, the wire X, this wire, and then press the reset button. For the wiring, you can use any USB, either this one, or you can use this one with CP2102 chip. You may use FTDI chip. All of these have one thing in common. Using this one, because it doesn't have 3.3 volts, make sure that you connect the 5 volts to the 5 volts pin of the camera module. 3.3 volts here, and then I have 3.3 volts. This one has plus 5 volts, this one has also 5 volts. Then we have TX RX, TX RX and ground. So they are the same. I'm going to use this one. The last pin is ground, yellow. I'm going to connect it to the ground on this side. After that we have RX connected to orange. RX will be connected to the UOT, this pin, the second pin, and then we have TX. I've connected red. TX will be connected to R, so the 3 wires which were connected in here, they are in order connected there. So this red module, the 3 pin will be connected. Yellow is at the first one, orange is at the second one, and red is the third one. And the last pin is 3.3 volts, brown wire. If you look here, 3.3 volts is in here. This is done. Now we need to connect a wire between IO0 and ground. I'm connecting this female to female jumper wire, IO0 and ground, and this is ready. Now let me show you how we can use Arduino Uno compatible or Arduino Uno actual board to program this. So I'm connecting 4 wires again. The 3 wires from this side will be connected in here. The last one is 3.3 volts in here. And remember, this is ground, and the last one is 3.3 volts. So 3.3 volts will be connected to 3.3 volts of Arduino. 3.3 volts will be connected to 3.3 volts of Arduino. The last pin is ground. Ground will be connected to ground in here. And here the pin that has been labeled as T, the green, have been connected here to pin 1. That is labeled here TX, which means bring your TX to this point. And the yellow with U0R, that is the RX. It has been labeled here to be connected to the pin 0 of Arduino Uno compatible or Arduino Uno board. First, we are preparing Arduino IDE with ESP32. I have separate video, but here quickly explaining that we need this URL for the board. I am right clicking and copying it. I will provide you this URL. Then go to your Arduino IDE and then click on File, Preferences, and at this section, Additional Board Manager, click on this link and you will see a lot of items here. If you have previously other stuff, just press Enter, and in the last line, right Control V, you will paste it. As you can see, I already have it, so I'm not going to do it. So I will delete it or not save it. You just click OK and then click OK. Doing this, we have set up Arduino IDE to find the boards. Click on Tools, Boards, Board Manager, and wait until this finishes, this bar graph. And then here type ESP32, and this says installed, and there is remove. In your case it will be installed, so just click. It will take few minutes or maybe seconds depending on your speed. Wait for this to finish and then close it. Let's select the board, click on Tools, Boards, and scroll down until you see ESP32 Rover module. Select that and then click on Tools, go to Partition and select Huge App. Then click on Tools and make sure you select the COM port that you have with your device connected. Click on File. We have to open the example. Go to Examples, scroll down until you see ESP32. Then on this menu, go to Camera and then Camera Web Server. We have commented out. Make sure to comment Model AI Thinker out. If you comment this out, this board will work for this module. You will enter your Wi-Fi SSID and here your Wi-Fi password. The rest is exactly the same. Do not change anything. It will just work fine. And here is the camera and the USB. I'm going to connect it. Once you connect it, you see the light is on. This has powered up, and also this one has power. Now we have to select the port that this USB is connected. Here is how you discover the port. Right click on your Start menu, go to Device Manager, and under the ports I have Silicon Lab CP221X 2102 and it says COM4. And I'm going to Tools, Ports, and then select COM4. Then click Upload. Now this is first compiling it and then uploading it to this board. Pay attention to this, that the blue will start blinking. And if it doesn't start, make sure to press this reset button. Once you press the reset, it starts working. And I'm scrolling so you can see it. and as you can see it's 100% and everything is completed. At this stage, let's remove this yellow wire and let's open the serial monitor. And I have this on the screen. And as you can see, it says Wi-Fi connected, starting web server port 80, and here is the IP for this module. Just copy this, or let's go to the web and open your favorite browser and then type the IP 192.168.0.111. I'm turning on the light. So if you scroll down, if you see this screen, it's a good sign. And here it says start stream. And as you can see, the video is starting. I can flip here. The video is flipped. Mirror. You can mirror it. These two are the most important one. And you see, this is a video. And here is underneath, you see that serial monitor is continuously streaming those values. And this is now, I will flip the video, and here is a video. It can show me. Now it's displayed. I have to look at this like that, so I'm looking at you. From here I can change the resolution, make it larger or larger, even larger. Let's see, it became very slow. It has some lagging, but it has video. So the larger the video, the slower the response. Let's make it very tiny. As you can see, it's a little faster because we are sending small frames of videos. So this is the original size that was default, and it has a lot of other features, for example negative and different color tint green, sepia, and here quality, brightness. You can play with those with a contrast. You can click here and get a still, and maybe from here you can save image as. Now the camera is connected. Let me open my phone, and I'm opening a new tab. Type the IP address 192.168.0.111 and enter. And here is the screen for it, and let me touch the stream. Once you touch it, the video appears underneath. It's shaky, and it's flipped, so I can flip the video from here. Now it's better. I'm holding it like this. So that's the video. Now let's upload the code using Arduino Uno compatible or Arduino Uno from Arduino IDE. Go to Tools, make sure the port is selected. In my case it's port COM11, and then upload. You will see the lights will blink in here. Let me turn the lights off. So you will see that they are blinking, and I have to press this reset button once at this point. When it is at this stage, you see now it starts. I'm scrolling so you can see it, otherwise it just stays at the top. And it is completed now. Let's remove this jumper. And let's open the serial monitor, check the IP. To do that, let's press the reset button. And it is connected to 192.168.0.1.1.1. Let me measure the current. I'm connecting it via this wire. Wait for it until it boots. Has not connected yet. 120 milliampere. Go to the web, refresh the page. When the stream starts, we will see what happens. 320 milliampere. Let me reduce the resolution. More. Thank you for watching. This was the setup and how to use this ESP32 camera. If you learned something and found this useful, please thumb up the video, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. And if you want to get updates of my upcoming videos, make sure to subscribe directly, and also clicking on the still. So the picture was taken. And let me open now the SD card. We have these files, foo, inside hello world, and then info, saved one JPEG file, and then this test.txt. It is just blank file with blank empty spaces, but the capacity is 1 megabyte, and here is the saved picture. I have some lights here, so do not consider the same picture if you take without the light.